9702, paper 4, variant 2, October November 2023, and the question number is 1, and which is related to the chapter first, circular motion. Define radian. We know we in almost every question you will have a definition based question of 1 or 2 mark. So this is the most relevant and the most frequent asking question in circular motion. Define the radian. The angle subtended by an arc at the center of the circle is equals to 1 radian. That is how we explain when there is a definition related to a unit. Right? So, a minute hand clock revolves at constant angular speed. Let me have this here. Angular speed around the force of the clock, completing 1 revolution every hour. A small piece of modeling clay is attached to the hand with the center of gravity at a distance L. So this is what a radius actually. A small piece of modeling clay is attached with the center of gravity at distance L from the fixed end of the hand as in figure 1.1. So it is rotating clockwise. Now calculate the angular speed. So we know the formula for the angular speed is either omega equals 2 pi over t if it is completing 1 complete rotation, or we can have this equation like omega equals the angular displacement over time. So angular displacement we will convert into the linear displacement, which is s over r. So we s over r, and s is the complete rotation. If we consider it, it will be 2 pi r. So the final value is now omega equals 2 pi over capital T, which is the period. So it's as the question says, as it has been 1 complete rotation. So 1 complete rotation means as the time is 60 minutes, and the 60 minute convert to seconds, so it's 60 into 60, and we got 0.001745, and keeping the value in the up to 2 significant figures, so it will be 1.7 into 10 power minus 3. Right? During a time interval of 1400 seconds, the center of gravity of the piece of the modeling clay moves through a total distance of 0.44 meters. Calculate the angle through the minute hand moves in the same interval, in this time interval. So we know the formula: angular speed equals angular displacement upon time. So angular displacement, which is actually the angle, right, is omega into time. Omega we already found out, which is 1.7 into 10 power minus 3, and time is given is 1500 seconds. So we will have 2.38, which is again up to 2 significant figure is 2.4. Determine the distance L, which is actually the r. So again we have the same formula: delta theta equals delta s over r, the relationship between the angular and the linear displacement. So we get from here is L, delta s over delta 3, delta theta 0.44 is given, 2.38 we got earlier, so it will be 0.1848. So again up to 2 significant is 0.18 meter. Calculate the magnitude of the centripetal acceleration of the piece of the modeling clay. So we will have the formula A equals, which is the centripetal acceleration, equals r omega squared. So A equals r, which is L, right? We already found to be 1.18, and omega you already found out previously. So in order to reduce the uncertainty, so we are using the actual value is 0.001745. So we will get 5.48 into 10 power minus 7. So again up to 2 significant figure, it is 5.5. So there is another way we could get the value of 5.6. So any value in between 5.5 and 0.16 will be considered as correct one. Right? Now use this is the main core of the whole question, because every part is a normal, no difficulty level, but this part this part says what? Use your answer C3, which is 5.5 into 10 to the power minus 7, and to explain why the variation with time, remember this point, variation with time of the magnitude of the force. So the force with the time with the time passing having no significant change, means centripetal force is not changing, right? So exerted by a minute hand on the piece of the modeling clay is negligible. So we are ignoring it, as the minute hand undergoes one full revolution. Now, what we need to understand first, we know the centripetal force formula, which is m omega square r, right? So, or in other word, m l omega squared. So L is fixed, right? And mass is fixed, and angular speed is also going to be fixed. And from this, what we actually got, the acceleration, centripetal acceleration, which is here omega r omega square, so which is already we found 5.5 into 10 to the power 7 meter per second square, or radian per second square, right? Actually it is meter per second square, right? So we already found, and which is very less, 10 to the power minus 7, right? So but so here in this case, if we say force is constant because speed is constant, is incomplete, right? So we will not get any mark, right? So if we are saying force is constant because the speed is constant, we need also to be explained like radius, change in radius is negligible, right? There is slight the clay is actually sticking on the minute hand, right? So this may be sticking out, or maybe slipping out. So this is very less, so we are ignoring this change, right? So what we will say, right? So as we know, the formula as the centripetal force is given by m r omega square, the angular speed is constant, right? And although the mass is constant, so we are useless to say about the mass, right? And the L, which is the distance, right, is changing, not significantly, right? It's not changing significantly. So the magnitude, so everything is constant, not changing. So the magnitude of centripetal force with respect to the time is not changing significantly, so hence it's negligible, right? Maybe in few wordings, maybe more or less I've made, but we need to make the concept, right? The concept is, if we say as like mass is constant, length is constant, and angular speed is constant, so that make a constant centripetal force. So with respect to time there will be no change. So this thing will be incomplete until and unless you explain about the L, the change, the length or the radius which is changing, but that change is not so significantly that can be measurable, right? And that make the and also the centripetal acceleration, which is constant value, is very small, right? So this is what exactly you need to write at the last point. I'm telling you this because this part especially is the core of question number 1. So examiner will decide whether you have a good concept for the circular motion. So this is the decisive part. Okay, so what we are saying, that the angular speed, as the angular speed is constant and the L, which is the radius, is changing but not significantly, right? So the magnitude of the force with respect to time is also not changing significantly, hence it's negligible.